Oxygen has 8 electrons, 2, 4, 6, 8. Oxygen has 8 electrons, 2, 4, 6, 8. So each oxygen is happy. So, hey, we got 8. We're happy. Carbon is crying. You guys are not fair. I only have 4. I need 8 as well. Well, we don't have any more. What are we going to do? Sharing, sharing. Take this pair out. The oxygen, you be nice. Put it in there. Take this pair out. Oxygen, you be nice. Let's share. We have a double bound between carbon and oxygen, carbon and oxygen. In this case, each oxygen still has 8 electrons. 2, 4, 6, 8. 2, 4, 6, 8. And then you look at carbon. Carbon with 2 double bound, a total of 8 electrons. Carbon is also happy. Now we have the Lewis structure for carbon dioxide. This is the guideline, the information that you have to remember. This is the practice that I want you to go through. And make sure you do the practice and try to do as many as possible. Remember, you're still in chem is tri-class, okay? And try to do as many as possible. We gave you quite a bit of exercise and homework there and asking you to draw a Lewis structure. And I may have maybe 2 or 3 minutes left here before I have to wrap up this lecture there. So let's do one more here. Okay, one particular situation. Now remember those guidelines. I know it may be a little bit too much if I ask you to recite whatever it is on the previous slide. I can't even do that myself. So well, let's just do the practice. Okay, one of the formula there: carbon 2, hydrogen 6, oxygen 1. Write the Lewis structure for this molecule. How do we start? Well, we need to draw skeletal structures for this atom here, for this molecule here. Now, the central atom is going to be the one with the lower group number. Hydrogens are always going to be terminal atoms. Okay, so the ways to connect the atoms together, one of the ways would be carbon, carbon, oxygen. Okay. The other would be carbon, oxygen, carbon. Now you have hydrogens involved in here. So to the hydrogen, hydrogen is always going to be the terminal atom there. So it is possible that hydrogen is attached to the oxygen. One of the hydrogen is attached to the oxygen. In that case, oxygen is the central atom. Hydrogen would be the terminal atom. Or you can have the carbon and oxygen connected to one another. You end up with this particular structure. Okay, so we have 6 hydrogens. We have to distribute 6 hydrogens. That's 5, 6. Okay, or in this case, six hydrogens. Now the next step in the guideline on the previous slide says you have to determine the total number of valence electrons. Here, carbon is group 4A. 4 times 2, we got 8 electrons. Hydrogen group 1A, 6 electrons. Oxygen group 6A, 6 electrons. So we have 20 electrons. Total number of valence electrons, we have 20. Now this is one way the atoms are connected to one another. Each dashed line represents a pair of electrons. How many valence electrons have we used in this molecule? Well, we can 2, 4, 6, 8, 10, 12, 14, 16. So we used 16 of the 20 electrons in this particular structure. We have 4 more left. Now it's time to apply that octet rule. Each hydrogen has to have 2 electrons. Okay? Well, all hydrogens have 2 electrons. Connecting to another atom, bound with another atom, there are 2 electrons in it. Carbon has 8 electrons, 2, 4, 6, 8. Carbon has 8 electrons, 2, 4, 6, 8. Oxygen has 2, 4. Oxygen is not happy. Oxygen needs 4 more. We used 16. We have 4 more. So we're going to put, that will make oxygen happy. That will be your Lewis structure. What happens to this particular structure? Well, 2, 4, 6, 8. 2, 4, 6, 8. Each carbon is happy. Each hydrogen is happy. Oxygen, 2 and 4. We used 16 electrons out of the 20. Lewis structure. Now wait a minute. You got one formula, 2 Lewis structures. Which one is correct? Both. Know what this is? An organic molecule that we none of you drink.
Alcohol?
Alcohol. This is ethyl alcohol. The alcohol in the alcoholic beverage. Okay. This is the Lewis structure of that alcohol. This is dimethyl ether. Now the importance about Lewis structure when it applies to organic chemistry is that in organic chemistry you could have formula molecules with the same formula but different structure. Different structure means different ways to distribute electrons among those different atoms there. Atoms' connectivity are different. This is what we call a constitutional isomer. They share the same formula, but they have different structure. These are, you can't drink dimethyl ether, I guarantee you. Alcohol, that's gonna knock you over. You can drink a little bit of alcohol. No, don't do that. Well, alcohol is okay if you consume a little bit of alcohol, but dimethyl, no, that's a toxic chemical there. Completely different chemicals. Belongs to 2 different categories of chemicals. Lewis structure will tell you which one is which. When you write out the Lewis structure, you see how the electrons are being distributed. If you only write out C2H6, oh, we don't really know what you're talking about. Are you giving me some of these, which is good, or are you giving me some of this, which is not good? Okay. So Lewis structure will tell you the exact distribution of electrons. Yes.
What if you took the one hydrogen, like on the left one, and put it on the oxygen, and then took those, you see what I mean? Like put 2 hydrogens for each of the core atoms.
This way.
No, like the hydrogen all the way on the left.
Mm-hmm.
Like all the way on the left.
Oh, this
Yeah,
one?
yeah. Take that one off.
Okay.
And then just put it there, and then put another on the carbon.
On this one?
Yeah. And so now each of them have 2 hydrogens. Like what's that one called?
Well, in this case though, 2, 4, 6, 8, that's still a viable Lewis structure in the sense that each atom is happy with 8 electrons. Very good question there. Now why does hydrogen, why is hydrogen has to be on here? Well, the thing here is that the central atoms, you only distribute the electrons to the central atom after you finish distributing all the electrons to the terminal atom. That's one of the guidelines here. Okay. So you don't want to have a central atom with lone pair if you have hydrogens around. Okay. Therefore, the only way to connect the hydrogens to the central atoms is that you put the hydrogens around the central atom. And this is, I mean, technically speaking, each atom is happy with 8 electrons, hydrogen with 2, but you don't want to put a lone pair on the central atom when you do have other atoms available. Okay, and in this case, and one of the hydrogens available, and also carbon is less electronegative, so carbon would not want to have a lone pair on itself. Oxygen is more electronegative. Oxygen is group 6A, carbon is group 4A. So oxygen would be okay for oxygen to have lone pairs on it because it has a stronger ability to attract electrons to itself. So a lot of details about the